Hey, what's up guys? My name is Cherno. Welcome back to my Game Engine series. So last time we talked about cameras and we created an orthographic camera. Definitely check out that video if you haven't already. And today, in this special midweek episode, we're actually going to be moving a lot of our code into the actual Sandbox application. And I'll show you guys a few tricks with how you can kind of set that up in a bit of a better way. So I decided to make this a midweek episode just because it's kind of like a minor change. We're not really learning anything new. We're just refactoring code and moving it around. And so I didn't think it would be fair to you guys if I just kind of made a new video on like Sunday as usual, and then it's just like this major disappointment. Not that this is going to be a major disappointment. You should definitely still watch this video, by the way. But let me know what you think about midweek episodes in general. As we kind of move on with Hazel and we start doing more and more stuff and it gets more exciting, I might consider doing 2 episodes a week. So just drop a comment and let me know what you think about that. And I might do that in the future. Patreon.com/Cherno is the best way to support this series. Thank you to everyone who made this series possible. If you go ahead and help support the series there, you'll get access to my private development repository of Hazel, which we've got much more advanced code and all this stuff. And then you'll also get videos early, and you can get access to a private channel on Discord where we kind of talk about these things in more detail, and you can kind of just essentially help plan these videos, which is really cool. Okay, so let's refactor our code. So last time we had this whole camera system, position, rotation. I also gave you guys some homework to actually see if you could make the camera respond to user input, and we'll actually do that today as well. That's going to be the fun part of today's video. But what we need to do first of all is, I don't like that this stuff obviously is inside application. We have a Sandbox app. If we look over here, it's an actual separate application. This is our exe file. Hazel is just a static library at this point. This Sandbox app is where everything should exist. So let's talk about how we can do that, because this example layer, this kind of sandbox that we have here, this example, that is our game essentially, right? And it could be like just a 3D application, doesn't have to be a game. But in this case, this is kind of our app. Right? This is our actual application. So this is where all of the code that is specific to this application should be. First thing I'm going to do is clear all this stuff up. We have like example layer, which is fine. We have on update, which at the moment just tests out like input polling, so we can get rid of that. We also have a test GUI render window, which we don't need either. And then we've got an on event. When we press a certain key or whatever, it this is the kind of responding to event, to input events rather than polling. So we can get rid of all that code because we don't need any of that. Now let's go into application and start carrying the stuff across. So this while running loop is actually kind of what we need. So I'll just cut this all, and I'll leave this stuff here, which is basically just layer updating and also GUI updating. This is our main kind of game loop, I guess, our application loop. And then over here, I'll just put this into on update. Now this isn't going to immediately work, and we'll have to refactor some code to make it work. So let's go ahead and do that. I'm going to add some private members into this example layer. If we go back to application, it's basically going to be everything that we used. So we had all this shared pointer stuff. We had the camera. I think that's probably it. So the shader and the vertex array. I'll go back here, and we'll add this into our Sandbox app over here as just private fields. Now we're going to need some stuff to clean this up. Hazel should have everything we need. We haven't added stuff to Hazel in ages though, so we definitely need to kind of expand that. We've had nothing in the renderer, as you can see, is here. So let's just clean that up. So we need to have Hazel renderer. Let's see what's in here. We need to have all of this stuff really. So we could have renderer. We can have like render command. And again, remember, some things will include other things. Like for example, render command includes render API, right? Which includes vertex array. So you don't have to actually put everything in here, but it's good practice too anyway, because if I suddenly remove an include from renderer that everything else relied on, right? I'm going to have to include it manually somewhere else. It's going to break my code. I don't want that. So it's pretty good practice to say basically that everything that I definitely know I want in the actual Hazel API to be kind of public, right? That stuff should be included here. And I'm doing this in no specific order. It doesn't really matter too much. But I'm doing orthographic camera. Pretty much everything in that renderer thing should be exposed. Render API doesn't need to be, so I'm not going to add it there. But everything else I think, should be. Graphics context doesn't need to be either. Keep in mind, that doesn't mean that because they're not listed here that they're private. Obviously they're not. If something else, like renderer includes render command, which includes render API. So render API is actually accessible. It's just not listed here explicitly, that's all. Because it's not really needed to be used. So I might just do some We might just put all the kind of resources down here. Let's see. So we can have renderer and render command based render stuff, and then maybe like resources like buffer shader, vertex array, and then like other kind of renderer primitives here, right? So we kind of begin to have some stuff here, and we could put like a little divider here if we wanted to, that just kind of lets us know that this is renderer related things. Okay, and I think we need 2 more dots, maybe 1 more, it's kind of hard to tell. Yep, okay, good. Cool, so there we go. We've got our renderer stuff, beautiful. So now we need to actually make sure that we're in the Hazel namespace. Now I could just using namespace Hazel, I don't want to because this is an example and I want to really kind of just make that point of what is actually used by the example, right? So what is from Hazel and what isn't. And currently we just have shared pointers defined here. I think in the future we are going to actually create a new name for shared pointers that we can use. But that's going to be another video. We'll talk about that later. So this will also be like a Hazel construct because in the future we also might want to change it to something else because we don't want to kind of rely on this as for memory management necessarily, right? Okay, orthographic camera is also Hazel. This stuff is Hazel. And so is that. Okay, brilliant. So now we need to actually create some of this stuff. Back in application, I'm gonna steal camera, right? Just gonna take that and cut it and put it here, right? And then this vertex array reset and just pretty much everything that we have here, all of our shaders, all of that stuff, I'm gonna cut it so that our application constructor goes down to just being as simple as this, right? And I'm going to paste it into, now there's a few places you could put this in. You can see that we have the Sandbox constructor, which does a push layer, right? And then push layer actually does new example layer and runs this code here. However, if we try and do that, you might find that it actually doesn't work. The reason is, what actually happens is this is application, right? Application constructor, well, actually, no, it should work because the application constructor creates the window and does all of that stuff. And only after that's done, because this is a default constructor, so basically it will be called, you know, like that, essentially, right? Just first, before we push this layer in, it should actually create our rendering context and everything. So it should be safe to do everything in the constructor if we wanted to. If it's not, then you can always create like an onInit function that definitely happens after, you know, stuff has been initialized, basically. So, and by stuff has been initialized, I mean specifically like the graphics rendering context, because we obviously can't create like all of these renderer resources before we have a context. Okay, so just putting the Hazel here. Again, I could use the namespace, but I don't want to because I want to be really explicit about what is Hazel and what isn't. Okay, and then we have shader. Because you can see like the clarity that this kind of gives us, right? We can see everything that belongs to Hazel. Okay, and I think that's pretty much it. Let's look over here in our code. I don't think we have anything else really. So that should just work, I think. Let's just try and run this code and see what happens. Okay, so you can see that running that code gives us the same result as we had in the previous video. So we've successfully refactored everything and moved it into the Sandbox app class. That was really easy to do. Now let's go ahead and see if we can add some kind of like arrow key input or something to just make our camera able to move, right? So to do that, let's come over here into onEvent and react to certain events. So this is going to be a really good example of the event dispatcher system. So if we open up the event file, we can see we have this event dispatcher which is capable of dispatching certain types of events. So we're going to use that by creating the event dispatcher, and it's basically just an instance, a stack instance of the dispatcher, right? Dispatcher, which is going to take in the event. And then we'll say dispatcher.dispatch, and then the type of event. So this is going to be a Hazel key pressed event, right? And we're going to use the, I think inside, where is it? Inside core maybe? We have this Hazel bind event function, which is what we kind of want to use, right? So this Hazel bind event function, and then we're going to give it a function here. So we'll say on key pressed event, and this is going to be Hazel key pressed event. So what is this? Example layer on key pressed event. I think that's it. That's all the macro needs. Yep, great. So we just put that in, and now if it encounters one of these, and this is, so let's see why that's not working. What is dispatch one? An event function, which is a function that returns bool. Okay, so yeah, this is void. Make sure we're returning bool. Okay, and yep, that error goes away. Great. So bool is whether or not we want it to like block. So because if you look at application, you can see that what happens is that we'll go through every layer and dispatch the event. However, if it's already been handled, then we break. So we stop dispatching it. We stop propagating it to further layers. With keep rest event, like we don't care. It can affect everything. We don't want to block and consume the input. It doesn't matter if you return true or false in this case, because we don't have any other layers where key events are going to be blocked. I think ImGUI does its own handling, so it's not going to block it from that anyway. But if suppose we did have like a UI layer, and when you type in the UI layer, you know, like you don't want, you know, because you have like a text field in your UI, you don't want the character to move if you type the WASD keys, because you're entering text. That's at which point you return true when you want to block that. Okay, so let's check this out. So if event get key code is HZ key left, I guess, we'll move left, right? So the way that we'll do that is we have this camera, which is great, but I'm actually going to have a GLM vec3 camera position. Okay, and we're gonna start off this camera position over here inside the constructor as being just 0, right? So I don't know if we can supply a 0 like that. Can we actually? I don't think we can. Let's see if that even compiles. Because I think that we need to specifically use 3, or maybe not. Maybe that will work. Yeah, okay, good. Yeah, it should. So there's a constructor that just takes a scalar. So in this case, right, we want to take that camera position and we want to move it left, right? We're moving the camera left. So to do that, we just say .x minus equals a certain speed. So m camera speed, we'll say. Okay, and this will be a float that we define here, for example. So float m camera speed, we're going to start it off as being like 0.1 or something, which is probably going to be too fast. Now at the moment, I mean, there's a huge problem here, right? Because events get dispatched every frame, right? This is going to be kind of dependent on our actual speed of movement, our actual like rendering frame rate, or how fast our application runs. We do want to use something called delta time, and most likely I would not really, like, you might not want to do this as an event. You might want to just do this like in the onUpdate function via polling, right? And I can show you guys how to do that as well. But to do that properly, we'll need to actually find out how fast our application is running and calculate something called delta time, so that we actually move the camera independent of how fast our application is actually running. Because of course, even if we have vsync turned on, which would mean that this app is running at 60 frames per second or 60 updates per second, if someone has a 144 hertz monitor, for example, it'll run at 144 times per second, unless it's like not able to render that quickly. So in which case the camera will move faster. So that's stuff to think about that we'll do in the future. But for now, really easy stuff. We'll do key left, we'll do key right, which basically increments our camera position, right? By the speed, so we move right, and then up and down is going to do the same to Y. So if we move down, we want to move the camera down, so negative, and then if we press the up arrow, we want to move it up. And then finally, what we want to do is inside onUpdate, before we do this stuff, we want to set our camera's position to be m camera position. Okay, we won't worry about rotation yet. I'll just leave that at 0. Let's hit F5 and see what happens. Okay, so here is our app, and if I press left or right, you can see it moves. Now, this is a key pressed event, and as you can see, it's only reacting when the key is actually pressed and then repeated, right? So we get this kind of really chunky movement. It's not really what we want at all, because it's an event system, right? It reacts to key presses. It means that I can just be like blah, 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 like I'm pressing left here, right? Doom, 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 and I don't know what's up with these weird noises I'm making, by the way. But anyway, it's moving my actual camera that amount, which is great. This stuff is great for like if you want to navigate through a menu, but if you actually want smooth in-engine gameplay or whatever, and you want to actually move your character or your camera properly, this stuff is rubbish. So let's go ahead and not use an event system and use and use our onUpdate function like you're supposed to, okay? So let's go over here into onUpdate, and instead of doing all of this stuff, we just want to say if input is key down or is key pressed, HZ key up or whatever. In fact, I'm just going to copy this stuff because it's going to be stupid. So instead of writing event get key code, we instead do is key pressed. Just like that. And of course this is Hazel input. So we can copy this and put it all everywhere over here. Right, so now what should happen, and we'll obviously get rid of all of this stuff. And in fact, I'll get rid of this completely because we don't need it right now, and I want to keep this code pretty lean. What we're going to do now is just hit F5, and now in the update loop, whenever we, like if the left key is pressed, every single update, it will actually move our camera. So this should be completely smooth, and this is the kind of stuff that you would expect from an actual game. So as you can see, when I move right now, it moves, which is awesome. Now, if you have a high refresh rate monitor, it might move so quickly that it just moves off the screen, right? If you've got VSync turned on. If you have VSync turned off, then like rip, right? This is gonna just run at 1,000 or 2,000, 4,000 frames per second, and you're not gonna see this at all. But you can see at 60 times per second, this isn't bad. Okay, so that's it. We can move our camera. Let's see if we can rotate our camera as well. So what I'll do is I'll just say that if we have, oh, and by the way, what you probably should do is like an else if or something for up and down. Otherwise you can actually end up canceling each other's like movement. So I'll say that, we'll say else if, and if we do that, it means that this key has precedence over this key, which is usually fine. I might say up has precedence over down though. So up moves it up. Okay, cool. So there we go. So if, I might say if the A key is pressed, right, we might say that the rotation, camera rotation, which I don't have, let's make a float called camera rotation. We'll set that equal to 0. If we press the A key, camera rotation minus equals camera speed, I guess. You should probably break this up and have like a camera rotation speed. So we'll say camera move speed. I'll refactor this, Alt Shift R with Visual Assist. Camera move, whoa, what did I do? Camera move speed, not camera move rotation. Camera move speed, and then camera rotation, and then camera rotation speed. Okay, whoops, I don't know how I did that. This is obviously just gonna be that, and I'll do 0.1 for this. So that way we can have an independent speed for movement and for rotation. So we'll say camera rotation minus equals camera rotation speed. And then with the D key, we'll say that it rotates in a positive direction. Okay, so let's see what we get here. All right, so A and D do absolutely nothing because of course I forgot to actually plug in camera rotation into our rotation. We're still setting our rotation to 0, so let's just do that properly and then see what happens. All right, there we go. So that A and D rotate the camera. That's very slow though, because it isn't, I guess it is in degrees. So we probably want to change this more to like 2 or something like that. And furthermore, you can see that you might see that it's actually rotating it the other way. So when I do minus equals camera rotation speed, it's actually rotating, it almost looks like I'm rotating the object instead of the camera, because it should be going the other way, shouldn't it? That's because a positive rotation actually rotates this way, right? And a negative rotation rotates clockwise. That's just the way that it works. So because of that, you actually want to do a plus equals to the camera rotation speed if we press A, and if we wanted to rotate we want to rotate the camera left, and then minus equals, or do like a negative rotation if we press the D key. So let's fix that and press F5, and we should get this, right? So now I can basically move my camera, right? And I can rotate my camera, and that all works as you would expect, okay? So now we have a moving thing. It's kind of hard to tell because we're just rendering one thing. pretty easy for us to change it. Oh wait, it's not, because at the moment, the way that we render things is only by our vertex positions. So what we actually need to do is be able to render objects in different positions, right? Which we can't do right now. When we submit something, that's it. It's just like a vertex array with its baked vertices and then a shader. We have no way of saying, I want this object to have this transform. So that's something that we need to do. We might do that next episode. The other alternative is this stuff, as I said, right now is bound to actually just be the speed at which our application is actually updating. We want this to be independent of that. So we need to introduce something called delta time and basically do proper time kind of step management. So that's another option of what we can do. We'll probably do one of those two next time. I think I just want to get delta time out of the way because that's something that, you know, we should have pretty early on, and it will just enable us to fix all of our code kind of and make it actually run for all of you guys properly. Anyway, I hope you guys enjoyed this video. If you did, hit the like button. You can also help support the series by going over to patreon.com/the Cherno, where you'll get episodes early and access to the Halo development branch, as I mentioned. So we have kind of two things that I want to do here. Today we managed to kind of get everything out of the application class. Our application class is actually clean now. Actually, let's go back to the application class because I think that, no, I actually did. I thought that I forgot to remove stuff from the header file, but no, we're pretty good here. We can actually get rid of this Hazel API. We don't need that anymore. This stuff includes almost everything. Yeah, shader, buffer, vertex array, that's the stuff I was talking about. We don't need any of those includes anymore. It's important to clean up your includes if you don't need them anymore, because that's something that people often forget. But you can see that our application class is really nice and clean again, like 79 lines of code, beautiful. And our Sandbox app actually has everything. So that's good because it's actually an example of us using Hazel Engine to actually render something and even add interaction to it, which is pretty cool. Okay, so next time, we're probably gonna take a look at delta time and how that works and why we need it even in the first place. And that should be a lot of fun. So I'll see you guys in the next episode. Goodbye.